In part 2 of chapter 2, we have functions. Here, we talk about functions and also operations on functions or types of functions today. We say every function is a relation, but not every relation is a function. Here, we say the definition of function is this. A function f from set A to set B. Here we must have two sets, or we must have at least a set to take the function from a set to another. Okay, and we also can say we can have a function from a set to itself. We can say that also. Here, that means you must have at least one set f from A to B, okay? Or you can say f from A to A. We can say that. We also can say that f from B to B. That means at least you must have a set to define the functional. Okay? We say a function f from set A to set B. It's a relation. It's a relation with domain A and codomain B. Here, A is called domain and B is called codomain. Here we say if is from X, let's say A to B, A is domain. This set is called domain. And this set is called codomain. Okay. Here, the function must satisfy these properties. First, we say for every element in A, we must have an image in B. Okay, for every element in A, we must have an image for the element in A. Yeah, we say for every x in A, there is an element Y. We must have an image in Y. Okay, and here we say xy is in the function. Xy belongs to the function. Here, x is from the domain and y is from the codomain. And we say for all x in A and y and also z in B. Here, y and z are both in B. We say if f of x equals y and also f of x equals z, y and z must equal. They must equal, then we say f is a function. If they are not equal, means it's not a function. F is not a function. Here we say for every element in A, we must have only one image in B. We must have only one image in B for every element in A. If we have more than one image for any of the elements of A, we say f is not a function. And here you have relations and functions. The difference between relations and function. We say not all relations are functions. Not all relations are functions, but conversely it's true. We say every function is a relation. Every function is a relation, but not every relation are functions. Here, look at this. This is a function. It's also a relation. As you see, we have only two conditions on f to be a function. We say all elements of A must have image in B, and also every element in A must have only one image in B. We have these two conditions on this relation to be a function. Okay, as you see, A, B, C, and D. As you see, all of them have images. And let's check if any of these has more than one image or not. Look, for A, we have only one image. As you see, there is only one arrow which arises from A. For B, It's also, there is only one arrow here, C and D. Each of these has only one image, so it satisfies both conditions. It means this relation is a function. Okay, but here we say all functions are relations. This is a function, and it's also a relation. Every function is a relation, but not conversely. We say when to use which. Here we say when do we use functions and when relations. Okay, we say a function is used when you need to obtain a single result for any element in the domain. If we want to get only one result or only one image for every element in the domain, here in this case we use function. Here we have some examples: sine function, cosine function, and also tan function. These are functions. And relation, if we want to get multiple images or multiple outputs for each element of the domain, or for any element of the domain, in this case we use relation. Here we use relation when there are multiple mappings between the domain and codomain. That means if you want to get more than one image for any of the elements of the domain, we say at this case we use relation. And here we have an example. For example, students enrolled in multiple courses. For example, if we have student A enrolled, let's say, for 3 courses. Let's say Z1, Z2, Z3. This student enrolls 3 subjects, and student B enrolled in 3 more students, 3 more subjects. Let's say Z1, Z2, and Z4. Maybe look, as you see, for A we have 3 images. We have 3 different images for A, and also for B we have 3 different images. In this case we use relation. We will take some examples numerically. Here we say if A and B are sets and F is a function. Here it says F is a function. That means F satisfies both conditions. Okay, from A to B. Then, given any element X in A, given any element in A, the unique element in B that's related to X is noted by F of X. That means the image of elements in A are noted by F of X. For example, if X to be in A, so what's the image? The image is F of X is in B. This image, this in domain. So what's the image? The image is in codomain. The images are always in the codomain, and the domain are those elements that you find their images. Here we have an example. We have this function. F equals 1a, 2b, 3a. 1a, 2b, 3a. Here, these elements, the first ones, are in the domain. So that means f of 1 equals a, f of 2 equals b, and f of 3 equals a. Yeah, you can say f of 1 equals a, f of 2 equals b, and f of 3 equals a. Always the image of the first equals to the second. Okay. We have one the example. F is defined by x and x squared, x and x squared, where x is a real number. X is a real number. That means our domain is the set of all real numbers. And the function is, if you give any element to the function, it gets squared. Okay, here for each x, it becomes x squared. That means f of x equals to what? X squared. This is our function. This is our function. From the definition above, we can find the function. It says x and x squared. That means f of x equals x squared. So this is our function. And then what's the image of 2? What's the image of 2? What's f of 2? F of 2 equals what? Here we replace 2 in the function. We replace x by 2 in the function. Our function is x squared. If we replace x by 2, we get 2 squared, which is 4, as it's written here. And also for this, for f of minus 3.5, we say it equals minus 3.5 squared. Since the power is even, so the result is positive. 3.5 times 3.5 is 12.25. This is the result. And also f of 0 is 0 squared, which is still 0. F of 0 is 0, because here you see f of 0 is 0 squared, which is 0. We replace all of these elements into the function. I mean, we substitute this in the function. So this is a definition, and from the definition we found the function and then finding the value of some points. Now you have domain, codomain, and range. Range is always a subset of codomain. It's always a subset of codomain. It's the set of all those elements which are images for the elements of the domain. وهتلاقي الرينج شيء كودومين شيء دومين أو نرخانية هم أو element يعني ك فكان يبوري أصلا كودومين ده كودومين أشي معناه كودومين لنا كودومين الرينج شمال الرينج شيء رينج بريتيلا شيء بريتيلو element هاي كسهم ينبوها كإيميجي element كاني أي لو أنا element بيننا كودومين كسهم يبونا هات أسايا functional كشينيا. Okay, here the domain, if you have a function from set x to set y, is denoted by this. F is from x to y. So here what's x? X is the domain and y is the codomain. This is domain, this codomain. So what's the range? Range is a subset of codomain. Range is a subset of codomain. Yeah, it says the domain of f is the set x and the codomain is y. And the range is those elements in y which are image of element of x. Elements of x. Here we say is the set of all y, where y is the image of elements of x. Here we take x in capital X. This is called range. We have an example here. We have given this relation. It says f equals 1a, 2b, and 3a from set x to set y. It's a function from x to y. Here we should find the domain and range. We are gonna find codomain also. Okay, let's first write down the function here. This is x and this is y. What's the set x? Set x is 1, 2, and 3. How about y? A, B, and C. Let's draw the arrows. Here, from 1 to 8, that means you have this arrow. From 2 to B. From 3 to 8. It's okay if two elements have the same image. Okay, but it's not possible if we have an element which has two different images. Okay, I'm going to give you an example. Okay, here this is a function because all elements in X have images, and none of the elements in X has two different images. Each element كان X do image جوازينية بون من اللي هيك وقدو سامبر داني برابو A داني برابو B برابو دوان جواز أما penalty function. ولم أسعي أقدر do element همان image يعني ياخذ زيادة ليش كشان همان image يعني. Okay, this is a function, and also what's the domain? The domain is the set X. It's always set X. Okay, so domain equals X. How about codomain? Codomain is Y. Look, because codomain is always Y. How about range? Range is a subset of codomain. Range equals what? Equal range here. بريتي لو element ثاني Y كسهم ينبو هذا. كأبناء image element كان X. شو معناها؟ Yeah, it's only A and B. This is the range. Okay, this is the range. So range is always a subset of codomain. Here, let's solve it here. You say this is a subset of Y. Here we have another example. We have this relation R is defined by 1A, 2A, 3A, where X is 1, 2, 3, 4, and Y is ABC. We say that's not a function. Why? Let's see. First, it's easier to write down the diagram. Yeah, this is X and this is Y. F is a function from X, is a relation from X to Y actually now. How many elements do you have in X? 4. 1, 2, 3, 4. 1, 2, 3, and 4. And the elements of codomain are A, B, and C. Here we say the relation is defined by 1 goes to A, 2 goes to A, 3 goes to B. Here we have an element in X. We have an element in X which has no image. 4 has no image. So in this case, you say that's not a function. So it's not a function. Since 4 belongs to X, but it has no image. Okay, since 4 has no image, that's why we say that's not a function. It's not a function. It's a relation, but not a function. Okay, that's it. Even this relation is not a function. It's also not a function. Yeah, R is defined by 1A, 2B, 3C, and 1B, where X is 1, 2, 3, and Y is ABC. Let's draw the function as a diagram. Here we have X, and this is Y. X is 1, 2, and 3, and Y is A, B, and C. Here we say A goes to A, to 1. Sorry, 1 goes to A. 2 goes to B. 3 to C. And also we have 1 and B. One has two different images here. Here, 1 has two different images. In this case, we say that's not a function. We say a relation is a function if it satisfies two conditions. First, if there is no element in X which has no image. The second condition is if all elements in X have only one image. Okay? We have these two conditions for a relation to be a function. Later, يك do image جوازية كاتنابت a function. It's not a function also. Here we say 1 and A and also 1 and B belongs to the relation, to the relation, but A doesn't equal to B. We say if any element of X has two different images, so the images must equal. If they are different, we say that's not a function, it's a relation. Now we have one-to-one function. We have one-to-one function. So let f be a function from set X to set Y. F is called one-to-one function or injective function. If and only if for all elements x1 and x2 in the domain, I mean for any two elements in the domain, if their images are equal, so they must equal also. Wata har elementek abe image na be do element haman image yani. Agar hatu do element ko ame sera o tan function balam heselere machiniya. Ame kaman seviyek haman image ya. Balam khwan eksani ame na beton. O function ke shiniya. Balam chiniya one-to-one. We say a function is one-to-one if for every two elements in the domain, if their images are equal, so they must equal. That means if f of x1 equals f of x2, then must x1 equals x2. Or equivalently, we can say if x1 doesn't equal to x2, then their images must different also. We say f is a function from x to y. The function f is called one-to-one. If for all x1 and x2 in the domain, if f of x1 equals f of x2, then x1 must equal x2. Here we take some examples. In this example, we have this function. F is a function which is defined by 1b, 3a, 2c from set X, which is 1, 2, 3, to set Y, which is a, b, c, and d. Here we say this function is one-to-one. How? Let's see. This is 1, 2, and 3. Here we have A, B, C, and D. The image of 1 is B. The image of 3 is A. And the image of 2 is C. That's all. Here we have only these three members in the function. We say this function is a one-to-one function. Why? Because for all elements in the domain, we have one image in the codomain. As you see here, I mean, for every two different elements in the domain, we have two different images for those two elements. Later, همو element كاني X image جواز معنا. يك image do image say image. أجر image do أنا example أو كاتن amount change 1 to 1 نيا. Yeah, it's a function. Look, the relation must be function, then we talk about one-to-one and one-to-one. Okay? If it's not a function, we cannot talk about one-to-one. Okay, that's in the codomain. We said if there is an element in the domain which has no image. It's okay if we have extra elements in the codomain. Okay? Now domain agar element siyahabu ala inabit a function. But I'm the yes, only X. This is X and this is Y. We say if we have an element in X which has no image, we say that's not a function. Okay? We don't talk about Y. So this function is one-to-one. And you have this example, which is not one-to-one. How? We have F, which is defined by 1A, 2B, and 3A. From set X, which is 1, 2, 3, and to set Y, which is A, B, and C. Here, we say the image of 1 is A, the image of 2 is B, and the image of 3 is A. As you see here, 1 and 3 are not equal, but they have the same image. They have the same image. That's why we say this function is not one-to-one. This function is not one-to-one. That's a function, yeah. كاتباسي one-to-one again. Let's say one-to-one calling now. I got function bit. I got function now, but history we not one. Okay. So the relation must be a function. Then we talk about one-to-one. And we say a function is one-to-one if for every different elements in X, we have different image for them. Okay. We have another example. It says, show that this function f of n equals 2n plus 1 on the set of positive integers is 1-to-1. If you have given a function and to show that the function is 1-to-1, we must prove it in general. We must prove it in general. Here, what's the definition of 1-to-1? We say if f of x1 equals f of x2, then we must show that x1 equals x2. Okay, here we say if f of x1 equals f of x2, so x1 must equal to x2 also. Here we have given this function. The function is f of n equals 2n plus 1. We are going to take two elements and we find their images. And we let the image are equal. So we must show that the elements are equal also. Yeah, we say let, or we say if, we say f of, let's say n1 equals f of n2. We must show that n1 equals n2. Okay, we must show that n1 equals n2. There I got do image example. If you do call example, وشو عم بريكين أبي بيسمين أمدو خالق وش نكسان and then it means the function is one-to-one. We say what's f of n1? N1 is here, we replace here. So f of n1 is 2n1 plus 1. 2n1 plus 1. We just replace n by n1 and we get 2n1 plus 1. F of n is 2n plus 1. How about f of n1? We say it is 2n1 plus 1 equals f of n2 is 2n2 plus 1. We must show that n1 equals n2. Okay, here we have an equation. In both sides of the equation, we have 1. We can subtract both sides by 1. Or you can say minus 1 for both sides. What we get? We get 2n1 plus 1 minus 1 in the left equals 2n2 plus 1 minus 1 in the right. And these two are cancelled out. And these two also. That means we get 2n1 equals 2n2. Here we have 2 which is multiplied by both sides of the equality. We have 2 times the left hand side and 2 times in the right hand side. So we can divide both sides by 2. If we divide both sides by 2, in the left hand side we get only n1 equals. In the right hand side you get only n2. Look, we said if f of n1 equals f of n2, and you obtain that n1 equals n2. As you see, n1 is equal to n2. Here, it means f is a one-to-one function. You see, thus f of n is a one-to-one. Is a one-to-one function. This is a one-to-one function. It's only that, and it's also proved here. It's all what I did. So to prove a function is one-to-one, we just pick 2 points randomly. Let's say n1, n2, x1, x2, anything else. Yes. You should know how to prove a function is one-to-one. As how to prove that a function is one-to-one. Let's take another example. Okay, let's take another example. If we say f of x to be square root of x, okay, minus 1. Is this function one-to-one or not? Let's check. This is a function, and to show this is a one-to-one function, to show that f of x is a one-to-one function, what we do? We just pick 2 points. Let's say x1 and x2. Her variable دايب. نابش معنى دايب. Okay? وهتبقى x يكو يكوزو دابني. أيو بي دابني. باشا ما لا في دو في سي. شتيوام منس. باشا we say let or if let f of, let's say, x1 equals f of x2. We must show that x1 equals x2. What's f of x1? We just replace x by x1 in the function. We get square root of x1 minus 1 equals f of x2 is, we replace x by x2, square root of x2 minus 1. Here, in both sides we have square roots. We can square both sides. Squaring both sides. What do we get in the left? x1 minus 1 equals. In the right, we get x2 minus 1. Now, we add 1 for both sides. Since in both sides we have minus 1. If we add 1 for both sides, we get x1 equals x2. So the function is 1 to 1. Okay. So f is 1 to 1. Okay. اما با proof نقشه كون سوري بس يعني اگر اف يكس يساوي بنقشه شلون بيسمين ام اف ام نقشه 1 to 1 ديم x1 x2 ايو بي ايو n1 و n2 هر شيء بيقول يقدم دو variable ولا يقدم لانه نقشه دانيم ودانيم ايميج كان نكسان ودانيم انجام كان كدانيم انه نقشه يكسان اما ما داناوا اف x1 يكسان ب اف x2 ابي تشيب سن ابي اوبسل من x1 يكسان ب x2 شلون اما جالنا نقشه دانيم انه هريك اف x شيء رقيك الزايده ناقصه اي اف دو شيء اكات الرقي دو ناقصه ونيا اي باشا اف x1 شيء لجي x1 داني so you get شي ما عندك الرقي x1 ناقصه عندك اي اف x2 شيء الرقي x2 ناقصه اما عندك get this او ما عندك دواي كاو ما عندك دين شيكين هاولين ايش يلعب لسركن بويك اكسك واكس دوب منيتو اكسك لا تشيك اكس لا راس منيتو شلون هردو لا رقي دو جاي رقي دو جاب بورد لا ورق كرقي دو جاب بورد لا ورق شي منيتو تنها جرا كام منيتو اكس ناقصك اكس 2 ناقصك لا دو ناقصك لا زائد بورد لا زياد شي معنى منيتو we just get x1 equals x2 وتماشي اگر اف كان اكسامبل يسلمني كخوشن اكس كان هذا سلمان ما ك اكس يك اكسان با x2 بلا هي for example let's take an example if I'm just gonna write down here f of x to be, let's say, x squared. Okay, that's a function, but not one-to-one. It's not a one-to-one function. Why? We say let x1 f x1 f of x1 equals f of x2. So we must show that x1 equals x2 if that's one-to-one. What's f of x1? We get x1 squared equals x2 squared. Taking square for both sides, yeah, we get x1 equals plus minus x2. Are these two equal? No. سيركا إلا كذا سكوير بورد لو يقدر يعني هنا في زائد ناقص وداني باشا هلوان أوكي لأجا هردو لا هنبو أو بو يقدر يعني سكوير وداني. Okay, so here we get x1, so x1 doesn't equal to minus x2. That doesn't equal to plus minus x2. Okay, it's possible if that equals to x1 and x2, but not to minus x2. Okay, so here we say if f of x1 equals f of x2, here we don't get x1 equals x2. That's why we say that's not a one-to-one function. And also we can take points. Let's take points here. You even can show that by taking points. It's better to show that a function is not one-to-one by taking points. Let's take points. -1, 2. Here, f of -2 equals to what? How about f of 2? F of -2 is 4. F of 2 is 4. Look, that means f of -2 equals to f of 2. But -2 doesn't equal to 2. Yeah, f of -2 equals f of 2. But -2 is not equal to 2. That's it. Okay? بمشي بيسلمين. بنمونه بيسلمين أجد نقشه 1 to 1 جمالي بول بقنو طاب. Okay. So that's an example about not one-to-one. And here you have an example. It's an example which is not one-to-one. We have given this function and says show that the function is not one-to-one. We don't need to prove it. If we just can find two elements which have the same image but they are different, means the function is not one-to-one. Let's take 2 and 4. Okay, if let's say n1 to be 2, n2 to be 4. Okay, or let's find f of 2 and f of 4. F of 2 equals to what? How about f of 4? What about f of 2? We say 2 to the power 2 minus both equal 0. Okay. Yes. F of 2 is 0. How about f of 4? Here we get 2 to the power 2 minus 2 to the power 2. For 4, we get 2 to the power 4 minus 4 to the power 2. These two are both equal to 16 and the result is 0. So in both cases, we get 0. As you see, we have two elements which have the same image. We say if the images are equal, so they must equal also. Then the function is 1-to-1. But they are not equal. 2 doesn't equal to 4. So f is not 1-to-1. So here we say this function is not 1-to-1. Why? Because we pick two different elements which have the same image, but they are not equal. So here we say the function is not 1-to-1. Now we have onto function. We say a function is onto if codomain equals to the range. If codomain equals to the range, that means for all elements in Y, we have images from all elements of Y are images of elements of X. Here we said before that if let's say we have 1, 2, 3, A, B, and C, if this goes to the and this is a function. And it's also it's not 1-to-1. It's not a 1-to-1 because 1 and 3 are different, but they have the same image. For onto, here we have an element in Y which is not image of any element of X. So here we say that's not onto. What element ما ولا Y كإيماج هيج element X نبو على الحالة يعني تشينيا onto. Okay. But if بلام أجر هاتو همو element كاني Y image element كاني X بون واتا هيج element إنما بقولنا Y كسهم يكون هات بيت أو كاتعلينا وشيا onto. So here in this example, it's not an onto function because C is in Y, but there is no element in X which have image C. Here you have an example. It says let X and Y, let X to be 1, 2, 3, and 4, and Y to be A, B, and C. H is a function from X to Y as follows. H of 1 is C, H of 2 is A, H of 3 is C, and H of 4 is B. And also K is a function from X to Y, was defined as K of 1 is C, K of 2 is B, K of 3 is B, and K of 4 is C. which of these two functions is onto and which is not? Which of these two functions onto and which is not? Let's first draw the diagram for H. X is 1, 2, 3, and 4. Y is A, B, and C. We say the image of this X to Y. Yeah, again, نقشه H will be image yakchia. What's the image of 1? It is C. As you see here, H of 1 is C. It's given that H of 1 is C. So image of 1 is C. And image of 2 is A. Image of 3 is C. Image of 4 is B. Here we have no elements in Y which are not image of elements of X. Okay, so this function is not onto function. It's not an onto function. This function is not an onto function. Sorry, it's an onto, not I said incorrectly. It is onto function. It's an onto function. Okay, why? Because there is no an extra element here which is not image for elements of X. هيج element ما وصلنا وياه كسهمي بنا هاتبت. So the function is an onto function. So H is onto. It's an onto function. How about K? Yeah, it says K of 1. Let's do it the same for K. 1, 2, 3, and 4. A, B, and C. This is K from X to Y. K of 1 is C. K of 2 is B. K of 3 is B. K of 4 is C. Here we have A in Y, which is not image for any element of X. Later Y, I am here now Y. K سهمي بونها. K image huge element X. So it's not onto. Okay. So for onto, we just look at the codomain. If the codomain equals to the range, we say that's onto. If not, we say that's not onto. Or if there is any extra element in the codomain which is not in the range, we say that's not onto function. It doesn't belong to K of X. Here, this is missed here. Should be doesn't belong to K of X. Now you have in the example, it says the function f from 1a, which is defined by 1a, 2c, 3b. This is the diagram. From X to Y, X is 1, 2, 3, and Y is ABC. The image of 1 is A, the image of 2 is C, and the image of 3 is B. Is this 1 to 1? Is this onto or not? How about 1 to 1? Okay, let's try both. This is a function. It's given that that's a function. So it must satisfy the conditions of function. And how about 1 to 1? We say a function is 1 to 1. If for different elements in X, we have different images for them. Okay, 1, its image is A. 2, its image is C. And 3, its image is B. كاتلير هيج دو element كنيرنا إكسا كهمان image يعني. كاتما 1 to 1. Okay, it's 1 to 1. And then for onto, هيج element ما لنا Y. كإيميج هيج element x نبي no so that's onto also it's both one-to-one and onto we have this example. It says the function f was defined by 1b 3a 2c is not onto y. Okay, here we say y is a, b, c, and d. This is y. And x is 1, 2, and 3. The image of 1 is b, the image of 2 is c, and the image of 3 is a. And here we have d, in y, which is not image for any element in x. Here you have d in y, which is not image for any element in x. So we say the function is not onto. That's for onto. Now we have bijection function. We say a function is bijection or one-to-one correspondence. We say a function is one-to-one correspondence or bijection function if it satisfies two conditions. If the function is one-to-one and also if it is onto. If the function is one-to-one and onto, that means if you have a function with both one-to-one and onto, we say the function is a bijection function. And also we can say it's one-to-one correspondence. Here we have an example. This is a function f from 1 to alpha, 2 to theta, and 3 to beta. Alpha, theta, and beta are images. Okay, image of 1, 2, and 3. This is one-to-one. Why? Because for any two different images in y, or for all different images, for all different elements in x, we have different images in y. For different elements in x, we have different images in y. As you see, the image of 1 is alpha, the image of 2 is theta, and the image of 3 is beta. Okay, there is no two elements in x which have the same image. That means that's one-to-one. And for onto, we say we have no any extra elements in y, which is not image for elements in x. This onto also. That means the function is one-to-one and onto. اللي بونتون اللي ارانهيج دو element من الاكس كهمان ايميج يعني هبت اما بونتو هيج element من ما ولنا واي كسامي بنا كواتما one to one. So the function is called bijection. We say the function is bijection. So for showing that a function is bijection, we must show that the function is both one-to-one and onto. Okay. And here you have a list of exercise for yourselves. Now you have inverse function. We say if f is one-to-one correspondence, means if it is bijective. So a function has inverse. If the function is bijective, that means if it's one-to-one and onto. If the function is not bijective, means we cannot find its inverse. كاتا inverse تنهابو أو نخشانا أتوين بدوسينو ك one-to-one onto. واتك bijective. And here we say if f is a one-to-one correspondence, means f is a bijection function from set x to set y, then the function then a function from y to x. Here we say if this is x and that's y. Here we have f is a function from x to y. And a function from y to x is called f inverse. Means the inverse function of f. If you return, I mean, when we say f of 1 equals 2, here we say f of minus 2, f inverse of 2 is 1. As you see, if you return, it's called inverse. This is f inverse of 2 is 1. Here we say f of 1 is 2, but we say f of 1 is 2, but f inverse of 2 is 1. The function, a function from y to x is called inverse function of y, of f, sorry. We say if f of x to be y, then f inverse of y equals to what? Equals x. These two elements. We have these two elements. We say if f of x to be y, then f inverse of y equals x. F of x is y, and f inverse of y equals x. Here we say f inverse of y equals x, if and only if y equals f of x. If y equals f of x. Here we have an example. Here we have given the function f. It says f is a function from set x to set y. X is 1, 2, 3, and y is a, b, and c. The function is defined by f of 1 is a, f of 2 is c, and f of 3 is b. That's it. This is a one-to-one and onto function. That means it's bijection function. What's the inverse of f? What's the inverse of the function? We say image of 1, f of 1 is a. How about f inverse of a? Yeah, f inverse of a is 1. How about f inverse of b? You see, the inverse image of b is 3, because b is the image of 3. The inverse image of c is 2. Here we say f inverse is what? F inverse of x equals to what? Equals to a and 1, b and c, c and 2. Is it? Look here, all of these are interchanged their places. Basha. So this is the diagram for the inverse function. Look, a goes to 1, b goes to 3, c goes to 2. Okay, this is inverse of the function f. This is f. The first one is f, which is in the left, and the right one, the one which is in the right, is f inverse. That's f, and that's f inverse. We have only this example. We are trying to finish this example, and it's enough for today. Here we say we have this the function f, which is defined from R to R. F of x is 4x minus 1 for all x in R. It says this function is both one-to-one and one-to-one. and on 2 and on 2. Find the inverse of the function. What we do in finding inverse of function. Okay, let's leave this for next lecture, for tomorrow.